Being a courier means delivering parcels to many different houses every day. At first, it may seem like a simple job. Alright then, let's start the day. However, many residential areas have complicated road layouts. I think I might have been here before, like before I transferred the previous parcel. Sometimes, even houses that are close to each other require a long route to reach. The houses were so close, but why does I feel it's still so far? Therefore, these are some of the challenges faced by couriers during daily parcel deliveries. Confusing road layouts and long travel distances often make their work more difficult and time-consuming. That is why this case study focuses on understanding these problems faced by couriers during delivery.
Alaikum and a very good day to everyone. I'm Nur Aisha Akilam Jamama Izzat from class JCDCS 103F. For our MAT210 group project, from chapter 4, we will present on graphs and diagrams, focusing on how these mathematical concepts can be applied to a real-life courier delivery problem using Hamiltonian paths and Hamiltonian cycles. Our objective is not only to define these concepts, but also to demonstrate how they can solve practical problems in logistics and route planning. In this project, we focus on 6 main concepts from graph theory, which is graph, digraph, vertex, edge, Hamiltonian path, and Hamiltonian circuit. These are fundamental ideas in discrete mathematics and are widely used in computer science, transportation planning, and network systems. Throughout our presentation, we will first explain each concept clearly and then show how they are applied in our courier case study. In any directed graph, each vertex has two important properties, which is in degree and out degree. The in degree of a vertex is the number of edges directed towards it. This tells us how many connections are entering that vertex. For example, in a road network, in degree represents how many roads lead into a junction. The out degree is the number of edges directed away from a vertex. This shows how many possible paths lead out from that point. According to a basic theorem in graph theory, in any digraph, the sum of all out degrees equals the total number of edges in the graph, and this is also equal to the sum of all in degree. This property is useful because it helps us check whether our graph model is logically correct and balanced. In addition, a vertex is also called a node, represents a distinct object or location in a graph. In mathematical terms, vertices or a vertex are the fundamental units of a graph. In our case study, each vertex represents a house or delivery location that the courier must visit to send all the customer parcels. By representing houses as the vertices, we can analyze the delivery system using mathematical rules instead of just relying on intuition. We are going to moving forward to edge. An edge is a connection or link between two vertices that represents a relationship or pathway between them. There are two types of edge, which is undirected edges that allow movement in both directions. And secondly, the directed edges which allow movement in only one direction that indicates by an arrow. In our courier model, we use directed edges because delivery routes often follow one-way streets or fixed directions. This makes our graph a digraph, or a directed graph than a simple graph. Next, a graph is a nonlinear data structure used to model relationships between objects. It consists of vertices and edges connecting them. Unlike arrays or stacks, graphs don't follow a strict sequence. Instead, connections can be random, hierarchical, or network-based. This flexibility makes graph very powerful for real-world modeling. For example, in a city map, intersections can be vertices and roads can be edges. Similarly, in our project, houses are vertices and roads are edges in a delivery network. A directed graph or a digraph is a graph where every edge has a direction. This is shown or indicates by using an arrow. If there is an arrow from vertex B to A, it doesn't mean there is automatically an arrow from A to B. This one-way property differentiates a digraph from an undirected graph. Digraphs are commonly used to model real-life systems such as one-way streets, flight routes, website hyperlinks, and courier delivery paths, which is why it is very suitable for our case study. Now we are moving forward to the very last, a Hamiltonian. A Hamiltonian has two types. Firstly, a Hamiltonian path is a path that visits every vertex exactly once, but does not necessarily return to the starting point. This is very useful when we want to cover all locations without forming a loop. Secondly, a Hamiltonian circuit, also known as Hamiltonian cycle, starts and ends at the same vertex while still visiting every other vertex exactly once. This concept is widely used in optimization problems such as delivering routing, scheduling, and traveling salesman problems. Now we are moving forward to our case study. For our case study, we focus on a courier responsible for delivering parcels, documents, and goods according to a schedule. Couriers play a very crucial role in logistics because they ensure items or a parcel reach their customers safely and on time. The courier also must manage their time very well, read addresses correctly, and plan their routes efficiently. Some deliveries may be urgent, which increases their pressure and risk of mistake. This motivates the need for a structured mathematical model, which we provide using graph theory.
Assalamualaikum and hello everyone. My name is Noshara Dayana and I will be presenting about the objective regarding this case study, which is method of sending packages from one house to another by using only one directed graph. So as we can see here, here's an example of house scattered around a post office waiting for their packages to be delivered. These are just normal graph and vertex with relation to each others. All these houses in this picture must have their packages delivered by today. Let's assume the houses are like vertex. Every vertex must be passed through only once and return to its original, which is begin from the post office and return to it at the end of the day. All the paths or the edges are not mandatory to be used. This method is called Hamiltonian cycle. Moving on to path 1, begin from K and at E. It is an example that can be used by using Hamiltonian cycle method. It also can be reversed, which is it can start from K end with I, or start from I end with K's. The result will still be the same. The most obvious observation here is that the whole connected graph looks circular. At the side, we can see the path used followed by the sequence of vertex or house connected. Moving on to path 2 is another alternative of the Hamiltonian cycle method. There are many ways to determine path of Hamiltonian circuit as long as the condition is met, which is begin and end at the same vertex, which the vertex is a post office, and all the other vertex only get passed through once. So this is the path used for path number 2, and again it can also be reversed and still return to the same. For Hamiltonian cycle, each vertex has a directed edges connected to each other. All the in degree and out degree only has one in and one out. What me and my partner can conclude here is that Hamiltonian cycle is relevant in this type of problem because it makes the courier easier to track down the path they previously took, just in case they happen to accidentally deliver the wrong package. And other than that, in this way the courier able to avoid wasting their time and avoid difficulties. In this way, the courier is able to avoid difficulties and avoid them from wasting valuable time. Hamiltonian cycle not only can be applicated in courier but also on other real-life operations such as computing. As an additional to our summary, me and Aisha also made some reflection regarding the real-life application that can be used by using Hamiltonian cycle method. For example, airline scheduling, which help determine efficient flight routes between cities, because they need to pick up and drop off the passengers from one city to another, or even international airline. Adding more, navigation app. Users such as Grab driver, Food Panda, Uber driver tend to use it a lot to find the shortest and most efficient path between location. Again, to pick up and drop off their passenger or even food. Another one is computing network. Inside computing, there are also algorithms which use looping, and it helps the programmer to code a lot more efficient, and the output has a good outcome. So back to courier and also anything close edits. If a courier delivers without planning, they might visit the same house multiple times over and over and take a longer route. By using Hamiltonian cycle, like how our project applicates, the courier can follow a clear systematic path and reduce mistake. As we all know, from a mathematical perspective, the use of Hamiltonian circuit in our project is important because it guarantees that every location is visited exactly once. This reduces redundancy in delivery process and ensures an organized sequence of movement from one house to another in real-world logistics, avoiding repeated visit on the same location, which can significantly reduce fuel consumption, travel time, and operational costs. In addition, the use of a directed graph is also very meaningful in our model because many real roads are one way. If we had used an undirected graph instead, our model would be less realistic, since it will allow movement in both directions even when it is not possible in real life. So it might end up confusing at some point. Therefore, combining directed graph with Hamiltonian circuit makes our case study more practical and applicable to real delivery system. Furthermore, this project demonstrates how abstract mathematical concept can be transformed into practical solution, not just industrial or logistic, but also real life. Although graph theory may seem theoretical in class, its applications are widely used in modern day technologies such as GPS navigation, route optimization, network design, and transporting planning. This shows that what we learn in MAT210 is not only exams but also relevant in real-world problem solving, which enhance the efficiency in real life. Therefore, this project successfully demonstrate how mathematical concept can be applied anywhere and solve so many things. That is all from me and Aisha. Thank you.